Welcome to the eastern seashore, where land meets ocean in an ancient rhythm that has shaped this coast for millions of years. As we begin our walk along this peaceful shoreline, the morning light catches the waves in silver flashes, and beneath our feet, the sand tells a story older than we might imagine. This sand you see stretching before us, it's traveled an incredible journey to be here. Much of it began as fragments of the Appalachian Mountains, eroded grain by grain over thousands of years, carried by rivers all the way to the sea. What was once towering peaks now cushions our footsteps, transformed by time and water into these soft beaches. Notice the darker, wavier line just above the high tide mark? That rack line is like a daily gift from the ocean, a tangled ribbon of seaweed, shells, driftwood, and treasures. But it's far more than debris. This narrow band of organic material becomes a vital nursery and cafeteria for the entire beach ecosystem. Small crustaceans called beach hoppers, or sand fleas, live within it, breaking down the seaweed and kelp. These tiny creatures, no bigger than a grain of rice, are themselves food for the shorebirds you hear calling overhead. Speaking of those birds, watch that small, quick-moving flock darting along the water's edge. Those are sanderlings, and they're performing one of nature's most charming dances. See how they chase the retreating waves, their tiny legs moving in a blur, then scramble back up the beach as the next wave rolls in? They're timing their movements perfectly to probe the wet sand during those brief seconds between waves, searching for small mollusks and crustaceans that the water has just exposed. These remarkable little birds may weigh less than 2 ounces, yet many of them fly thousands of miles from. As we continue walking, you might notice the beach changes texture beneath your feet, sometimes finer, sometimes coarser, sometimes even containing bits of shell. These variations aren't random. The Atlantic coast experiences different wave energy depending on the season and weather patterns. During winter storms, powerful waves carry away the finer sand particles, leaving behind heavier materials and creating a steeper beach profile. In summer, gentler waves return that fine sand, creating the wide, flat beaches perfect for walks like this one. The beach is literally breathing with the seasons, reshaping itself in an endless cycle. And those shells scattered around us? Each one represents a life lived in the waters just offshore. The Atlantic surf clam shells, smooth and white, can live for over 30 years in the sandy bottom. When you find one intact, you're holding something that filtered gallons upon gallons of seawater, extracting microscopic algae and helping keep these coastal waters clear. Look out toward the horizon now, where the water meets sky. The Atlantic Ocean along this coast contains massive highways of water called the Gulf Stream current, flowing like a river within the sea. This powerful current carries warm water from the Gulf of Mexico northward along our eastern seaboard, and its presence has shaped everything about this coastline, from the fish that swim here to the weather patterns that sweep across the land. The Gulf Stream moves more water than all the rivers on Earth combined, and its warmth moderates our coastal climate, making these beaches habitable for the rich diversity of life we encounter here. As we walk, notice those small birds working the surf zone alongside the sanderlings? Those are plovers, and they're not just randomly wandering, they're reading the beach. These birds can detect the tiny vibrations made by invertebrates moving beneath the sand. When they pause and tilt their heads, they're not looking at the surface but sensing through their feet, feeling for the movement of prey below. It's a reminder that there's an entire hidden world beneath this seemingly simple stretch of sand, a world of worms, clams, and countless tiny creatures living between the grains. The dune grasses swaying behind us are equally remarkable. Those seemingly fragile plants, particularly the American beach grass, are true coastal engineers. Their roots can extend more than 20 feet down into the sand, anchoring the dunes that protect the inland from storm surge. With each tide and wind, sand accumulates around their stems, and the plants simply grow taller, building the dunes grain by grain. Take a deep breath of this salt-tinged air. That distinctive ocean smell comes partly from a compound called dimethyl sulfide, released by microscopic phytoplankton in the water. These tiny organisms, invisible to our eyes, form the foundation of the entire ocean food web. They're the grass of the sea. They also produce much of the oxygen we breathe, making every breath you take on this peaceful shore a gift from these ancient, microscopic life forms. As we continue our journey, let the rhythm of the waves slow your thoughts, and remember, you're walking on a shoreline that's constantly being written and rewritten by wind, wave, and tide. As we continue our walk, the sun climbs higher, and the beach begins to reveal more of its secrets. Look closely at the sand near the water's edge. Do you see those tiny, perfectly round holes? Each one is the doorway to a hidden resident. Beneath the surface lives a small creature called a mole crab, or sand crab, burrowing backward into the wet sand with remarkable speed. These little crustaceans face the ocean, extending feathery antennae above the sand to filter passing food particles from the water. They're so attuned to the rhythm of the tides that they migrate up and down the beach with each tide cycle, always staying in that narrow zone where waves wash over the sand. In a single square yard of beach, there might be hundreds of them, creating an invisible city beneath our feet. Notice how the color of the water changes as you look from the shore outward. That milky turquoise near the beach gradually deepens to dark blue at the horizon. This gradient tells a story of depth and life. The lighter water close to shore is filled with suspended sediment and tiny particles, those same sand grains being tossed and carried by the waves. But it's also rich with nutrients stirred up from the bottom, making these shallow waters incredibly productive feeding grounds. This is why the shorebirds concentrate here, and why, if you were to wade in, you'd likely spot small fish darting through the shallows. Among those fish might be young Atlantic silversides, slender and translucent, traveling in shimmering schools. These small fish have a fascinating relationship with temperature. The sex of their offspring is determined not by genetics alone, but by the water temperature during a critical period of their development. Warmer waters produce more females, while cooler waters yield more males. As our ocean temperatures gradually shift with changing climate, these fish are living thermometers, adapting their populations to the changing world. As we round this gentle curve in the shoreline, you might spot something extraordinary if you look carefully at the wet sand, those delicate, lacy patterns that look almost like fossilized ferns. These are called swash marks or rill marks, created by the thin film of water flowing back down the beach after each wave. They're temporary art, existing only until the next wave erases them and draws new designs. But they reveal the hidden topography of the beach. Water always follows the path of least resistance, and these delicate channels show the microscopic valleys and ridges in what appears to be flat sand. And speaking of temporary beauty, have you noticed those iridescent bubbles of foam collecting at the waterline? Sea foam forms when organic matter, decomposing algae, fish scales, and proteins from countless marine organisms, gets churned up by waves and creates a natural surfactant, much like soap. It's a sign of a healthy, productive ocean, full of life both visible and microscopic. Listen to the changing chorus of bird calls around us. That high-pitched, laughing cry? That's a laughing gull, aptly named for its call that sounds like joy itself. These intelligent birds have learned to follow fishing boats and beachgoers, but their natural behavior is far more sophisticated. Laughing gulls can drink both fresh and salt water. They have specialized glands above their eyes that filter out excess salt, which they then excrete through their nostrils. This remarkable adaptation allows them to live their entire lives without ever needing to find fresh water, making the ocean itself their drinking fountain. The gulls share this beach with another master of coastal living, the ghost crab. You're more likely to see their burrows than the crabs themselves during daylight hours. These pale, sand-colored crustaceans are primarily nocturnal, but their presence is everywhere if you know what to look for. Those perfectly round holes, often with a small mound of excavated sand beside them, those are ghost crab burrows, and they can extend 3 to 4 feet deep into the beach, down to where the sand stays moist and cool. Each crab maintains its own territory, defending it vigorously from other ghost crabs. As we walk, the composition of the beach changes subtly. Here, mixed with the sand, you'll find more fragments of shell, evidence of the rich shellfish beds offshore. The eastern coast was once home to oyster reefs so vast that they were navigational hazards for early ships. While those massive reefs are largely gone now, the legacy of shells remains, ground down over centuries into the sand itself. In some areas, shells can make up to 20% of what we call sand. These shell fragments also serve a vital purpose beyond creating beautiful beaches. As they dissolve ever so slowly, they release calcium carbonate back into the ocean, helping to buffer the water's pH and maintain the delicate chemical balance that marine life depends upon. In this way, the shells of long-dead mollusks continue to support the living ocean for decades or even centuries after the creatures inside them have gone. Look up now, and you might catch sight of a brown pelican gliding just above the wave tops. These magnificent birds, with wingspans reaching 7 feet, use a technique called ground effect flying, riding on a cushion of air compressed between their wings and the water's surface. This allows them to glide for long distances with minimal energy, surveying the water below for schools of fish. When they spot their prey, they transform into diving missiles, plunging from heights of up to 60 feet with wings folded back, hitting the water in spectacular splashes. What's truly remarkable is that pelicans nearly disappeared from the eastern coast entirely in the 1960s and 70s due to DDT pesticide contamination, which thinned their eggshells. But thanks to the ban on DDT and dedicated conservation efforts, brown pelicans have made one of the most successful comebacks in conservation history. Every pelican you see soaring above these waves is a living testament to nature's resilience and our ability to heal the damage we've caused. As we pause here for a moment, feeling the breeze and listening to the eternal conversation between land and sea, remember that this beach is not a static place but a living, breathing ecosystem in constant motion, and you're part of its story today. As we continue along this peaceful stretch of shore, the beach widens before us, and you might notice something curious. The sand here feels different, almost sparkling underfoot when the sun catches it just right. Look closely, and you'll see tiny flecks of black mixed throughout the lighter grains. These are particles of magnetite, a magnetic iron oxide mineral that's denser than regular sand. The waves act like a natural sorting machine, and during certain tidal conditions, these heavier minerals concentrate in distinct dark bands along the beach. Ancient peoples along this coast knew these dark sands well. They're often found near freshwater streams entering the ocean, marking places where rivers carried minerals from deep within the continental bedrock to meet the sea. Following these natural signs, early inhabitants would find the fresh water they needed, and the wildlife that congregated at these mixing zones where salt water and fresh water create especially productive habitats. Speaking of mixing zones, notice how the water's edge is never still? Even on this calm day, waves arrive in sets, some larger, some smaller, in a pattern that seems almost rhythmic. This isn't your imagination. Ocean waves travel in groups, and what you're seeing is the result of wave interference patterns that began perhaps thousands of miles away. Waves generated by different storms at different times travel across the ocean, and when they meet, they interact, sometimes combining to create larger waves, sometimes canceling each other out to create smaller ones. What reaches our shore is a complex symphony of energy that began with winds far out at sea, maybe days or even weeks ago. The energy in these waves is remarkable. Even a modest wave crashing on the beach releases energy equivalent to several hundred watts, enough to power a handful of light bulbs. Multiply that by the thousands of waves hitting this coastline every hour, and you begin to understand the immense power that has shaped and reshaped the shore over millennia. As we walk, watch for the common terns diving offshore, those sleek, gray and white birds with the sharp black caps and pointed wings. Terns are among nature's most accomplished aerialists and long-distance travelers. The Arctic tern, a close relative that sometimes visits this coast, holds the record for the longest migration of any animal on Earth, flying from Arctic breeding grounds to Antarctic waters and back each year, a round trip of up to 50,000 miles. The bird you might weigh only 4 ounces but will see more daylight in its lifetime than any other creature, experiencing 2 summers each year as it chases endless daylight between the poles. Even the common terns here are impressive migrants, traveling to South America for the winter before returning each spring to nest on our beaches, often on the same stretch of sand where they themselves were born. Notice those small, silvery fish occasionally breaking the surface just beyond the breakers? Those flashes of movement are likely Atlantic menhaden, sometimes called bunker or pogies by fishermen. These unassuming fish are absolutely critical to the health of the Atlantic coast ecosystem. Menhaden are filter feeders, straining microscopic algae from the water. A single adult can filter up to 7 gallons of water per minute. Schools of menhaden act like living water purifiers, helping to keep coastal waters clear and preventing algae blooms that can choke out other marine life. They're also what biologists call a forage fish, a critical link in the food chain. Striped bass, bluefish, weakfish, tuna, ospreys, eagles, dolphins, whales, all depend on menhaden as a primary food source. There's a saying among fishermen, no menhaden, no fishery. This humble fish, often overlooked by casual beachgoers, is truly the foundation upon which much of the Atlantic's abundance rests. As the morning progresses, you might feel the breeze shifting. Coastal areas experience their own unique wind patterns, created by the different rates at which land and water heat up. During the day, the land heats faster than the ocean, causing air to rise over the beach and dunes. Cooler air from over the water rushes in to replace it, creating what we call a sea breeze. This is why coastal areas often feel cooler than inland locations on hot summer days. The ocean itself acts as a giant air conditioner. At night, the process reverses. The land cools faster than the water, and winds blow from land to sea, a land breeze. These daily wind patterns have shaped not only the human history of this coast, with sailors timing their departures and arrivals by these predictable breezes, but also the natural patterns of pollen dispersal, seed spreading, and even the hunting strategies of the insects and birds that live here. Look down now at the sand near your feet as we walk through this slightly darker patch. See those tiny, translucent specks? Those are grains of quartz, and they're among the most enduring substances on Earth. While other minerals weather and break down, quartz persists. Some of these individual grains might be millions of years old, recycled through countless cycles of mountain building, erosion, and deposition. That tiny crystal catching the light has a history spanning geological ages. It might have been part of an ancient seabed, compressed into rock, thrust upward into mountains, frozen in glaciers, and finally liberated to rest here under your feet. Quartz grains are also piezoelectric. They generate a tiny electric charge when pressure is applied to them. So with each step you take on this beach, each wave that crashes down, you're creating countless microscopic electrical pulses in the sand beneath. The beach is literally alive with invisible energy, responding to every footfall, every wave, every grain shifted by the wind. As we continue our peaceful journey, the timeless rhythm of the waves reminds us that we're walking through both space and deep time, where the ancient and the momentary exist together in this thin line where Earth meets sea. As we continue our journey along this tranquil shore, the sun now sits higher in the sky, and the beach reveals yet another layer of its intricate story. Notice those delicate, J-shaped impressions in the sand near the waterline? Those are the tracks of sanderlings we saw earlier, but look more closely at the pattern they create. Each little footprint tells a story of movement. You can see where the bird paused, where it pivoted quickly, where it probed the sand with its beak. Shorebird tracks are actually ancient navigation tools. Indigenous peoples of this coast read these signs like a language, understanding which birds were feeding, where, and on what, helping them predict the movement of fish and the changing of tides. But there's something even more remarkable hidden in the sand. The beach is home to microscopic creatures called foraminifera, single-celled organisms with ornate shells, or tests, made of calcium carbonate. When you pick up a handful of sand and look closely, some of those tiny white grains that look like sand aren't sand at all, but the shells of these ancient protists. Some foraminifera species have existed for over 500 million years, making them among the oldest surviving lineages on Earth, and their presence in the sand connects us to an ocean older than most life on land. As we walk, you might catch a whiff of something distinctly marine, that rich, briny scent that's stronger here than it was back where we started. That smell intensifies near tide pools and areas where seaweed is washed ashore because it comes from the breakdown of organic matter, particularly the sulfur compounds released as marine organisms decompose. But there's beauty in this process. What we're smelling is the recycling of nutrients, nitrogen, phosphorus, and trace minerals, being returned to the ecosystem. The bacteria breaking down this seaweed are feeding beach hoppers, which feed birds, which leave droppings that fertilize the dune grasses. Nothing is wasted here, everything flows in cycles. The seaweed itself, particularly the rockweed and kelp varieties you see in the rack, comes from underwater forests just offshore. These kelp forests grow with astonishing speed. Some species can grow up to 2 feet per day, making them among the fastest growing organisms on Earth. They provide shelter and food for countless fish, and when storms tear them free, they bring that productivity to the shore. Look out toward the water now, where you might spot a dark, rounded shape bobbing just beyond the breakers. That's likely a harbor seal, hauled out on a sandbar or swimming just offshore. These marine mammals are returning to the eastern coast in growing numbers after being hunted to near extinction in the 19th century. Harbor seals can hold their breath for up to 30 minutes and dive to depths of 1,500 feet, though they usually feed in much shallower waters close to shore. What's fascinating is their whiskers, or vibrissae, which are incredibly sensitive sensory organs. Even in murky water or complete darkness, a harbor seal can detect the wake left by a fish that swam by seconds earlier, following the trail of disturbed water like a bloodhound follows a scent. Each whisker connects to a nerve-rich follicle, giving seals a three-dimensional map of the underwater world around them through touch alone. In the coastal waters where visibility can be measured in inches, this adaptation makes seals supremely effective hunters. Notice how the beach here is punctuated by weathered pieces of driftwood, some bleached bone white by sun and salt. Each piece has made its own journey to the shore. Driftwood might have started as a tree growing hundreds of miles inland, eventually falling into a river, traveling downstream through marshes and estuaries, and finally being carried by currents to rest here. Some pieces of driftwood can drift for years, traveling thousands of miles across ocean basins before finding a final resting place. But driftwood is far more than mere debris. These wooden sculptures become their own microecosystems. Gribbles, small crustaceans related to pilled bugs, bore into the wood, creating tunnels that provide homes for other tiny creatures. Shipworms, which are actually mollusks despite their name, consume the wood fiber, breaking it down and recycling the nutrients. A single large piece of driftwood might support hundreds of species of invertebrates, fungi, and bacteria, all working together to transform the wood back into simpler compounds that nourish the ocean. As we continue walking, the character of the beach shifts again. Here, the sand gives way to patches of small, rounded stones, beach pebbles worn smooth by countless tides. Pick one up and feel its smoothness. The ocean is an incredibly patient sculptor. These stones have been tumbled in the surf zone for years, perhaps decades, each wave rolling them against their neighbors, grinding away sharp edges atom by atom. The smoothest pebbles are often quartz or quartzite because of their hardness. Softer rocks have already been ground down to sand. But there's a hidden rhythm to how pebbles move along the beach. During powerful storms, large waves can pick up even substantial stones and move them up the beach or along the shore. During calmer periods, smaller waves sort them by size and density. This process, called longshore drift, means that beaches are constantly on the move, sand and stones traveling along the coast in a slow migration that can span miles over the course of a year. The beach you're standing on today isn't the same beach that was here a month ago, even if it looks identical. Listen now to the more distant sound beneath the waves, a deeper, more resonant rhythm. That's the sound of the surf zone itself, where waves break and reform, creating complex patterns of water movement. This zone is one of the most dynamic and productive areas of the entire ocean. As waves break, they churn the bottom, bringing up nutrients and oxygen. They also create a phenomenon called undertow, not the dangerous rip currents we're warned about, but a natural flow of water back out to sea along the bottom. This circulation pattern creates a three-dimensional structure in the water, with waves bringing water towards shore at the surface and the undertow carrying it back at depth. Fish, crabs, and other marine creatures use these currents like highways, riding them to conserve energy. Young fish often travel with the undertow when they need to move offshore, while returning adults might ride the incoming waves. It's an invisible infrastructure that marine life has been navigating for millions of years. As the morning continues and we walk deeper into our journey, each step reveals that nothing here is as simple as it first appears. The beach is not just sand and water but a complex, interconnected web of physical forces, living creatures, and ancient processes, all flowing together in this peaceful meeting place of earth and ocean. As we round another gentle bend in the coastline, the beach opens up before us, and you might notice something peculiar, the way the waves approach the shore at a slight angle rather than straight on. This isn't random. Waves refract, or bend, as they approach the beach, responding to the changing depth of the ocean floor. The part of the wave in shallower water slows down while the part in deeper water continues at full speed, causing the wave to pivot. This is why waves tend to align themselves with the shoreline, regardless of the direction they travel from far out at sea. This bending of waves has profound effects on the shape of the coastline itself. Headlands, rocky points jutting into the ocean, receive concentrated wave energy as waves wrap around them from multiple directions, causing faster erosion. Meanwhile, the bays between headlands receive less energy and tend to accumulate sand. Over thousands of years, this process works to smooth out an irregular coastline, as if the ocean itself is carefully sculpting the land to create the graceful curves we walk along today. Look closely at the sand as we walk through this slightly damper section near the water. Do you see those tiny air bubbles popping at the surface? The beach is breathing. Sand contains surprising amounts of air between the grains. Sometimes up to 50% of the volume of dry sand is actually airspace. As waves wash over the beach, water infiltrates these spaces, compressing and trapping air. When the wave retreats, that trapped air slowly escapes, creating those tiny bubbles and the soft hissing sound you can hear if you listen carefully. This breathing process is essential for the creatures living within the sand. The oxygen in those air spaces allows worms, clams, and countless other burrowing organisms to survive beneath the surface. Some marine worms construct their burrows with such precision that they create a one-way flow, drawing oxygen-rich water in through one opening and expelling waste through another, essentially creating a personal plumbing system in the sand. As the morning sun climbs higher, notice how the beach changes color before your eyes? The wet sand near the waterline appears much darker than the dry sand further up the beach. This isn't just because it's wet, it's an optical phenomenon. Dry sand grains are separated by air, and light bounces between the grains multiple times before escaping back to your eyes, creating a lighter appearance. When water fills the spaces between grains, light penetrates deeper into the sand before reflecting back, and more light is absorbed in the process, making the wet sand appear darker. The same sand, simply saturated with water, can appear to be a completely different color. This shifting palette extends into the water itself. The color of ocean water depends on what's suspended in it and what's beneath it. Clear water over white sand appears turquoise, while that same water over dark rocks or seaweed appears deep blue or even greenish. The ocean is an ever-changing canvas, painting itself anew with each tide and shift of light. Listen to the cry of that bird soaring high above. That piercing call belongs to an osprey, a fish hawk that's made a remarkable comeback along this coast. Ospreys have evolved an extraordinary adaptation for their fishing lifestyle. Their outer toe is reversible, allowing them to grasp fish with 2 toes in front and 2 behind, like an X pattern, which provides a more secure grip on slippery prey. When an osprey dives for a fish, it can plunge feet first into the water and actually closes its nostrils to prevent water from entering during the dive. But here's what's truly remarkable. Ospreys have tiny spikes, called spicules, on the pads of their feet that act like the treads on a tire, giving them extra grip on fish scales. And after catching a fish, an osprey will rotate it in flight so the fish faces forward, head first, reducing air resistance during the flight back to the nest. It's aerodynamic precision born from millions of years of evolution, visible in a single moment of flight above our heads. As we continue walking, you might spot small, coin-shaped objects scattered among the shells, sand dollars. These delicate structures are actually the skeletons, or tests, of sea urchins that live just offshore in sandy areas. Living sand dollars are covered in tiny, velvety spines and are actually purple or reddish-brown, not the bleached white we find on the beach. These creatures burrow partially into the sand at an angle, positioned to catch organic particles drifting by in the current. The pattern on a sand dollar's surface isn't just decorative, it's a record of how the animal feeds. Those petal-shaped grooves contain hundreds of tiny tube feet that work together to pass food particles toward the mouth on the underside. If you look at a sand dollar from the side, you might notice it's slightly dome-shaped, and this curvature helps direct water flow over the animal in a way that maximizes food capture while the creature remains buried. The 5-pointed flower pattern on top represents the path of the water channels that carry oxygen to all parts of the animal's body. It's functional architecture disguised as natural art. Notice how the sound of the waves changes as we walk. Sometimes it's a gentle whisper, sometimes a deeper roar. This variation reflects the changing beach profile beneath the water. Where the beach slopes gradually into the ocean, waves dissipate their energy slowly, creating a gentler sound. Where the beach drops off more steeply, waves break with more force and volume. The beach is singing to us, and if we learn to listen, we can read the underwater topography by sound alone. The frequency of the waves, how often they arrive, also creates patterns in that sound. Ocean waves typically arrive in sets of about 7, with the 3rd through 5th waves often being the largest. This pattern emerges from the way different wave trains from different storm systems interact and combine. Surfers have known this rhythm for generations, waiting patiently for the largest waves in each set. But even here on our peaceful walk, you can count the waves and feel that rhythm, a pulse from the heart of the ocean itself, reaching across miles of open water to touch the shore at our feet. As we pause here for a moment, feeling the sand beneath our feet and the salt air in our lungs, we're reminded that this beach is not a static backdrop but a living, breathing, ever-changing meeting place of countless forces and forms of life, each contributing its own note to the symphony of the shore. As we enter the final stretch of our peaceful journey, the character of the beach shifts once more. Notice those small, cone-shaped depressions in the dry sand above the high tide line? Each one is the hunting trap of an antlion larva, though along the coast they share this habitat with tiger beetle larvae, equally fierce predators in miniature. These tiny architects excavate conical pits in the loose, dry sand, then bury themselves at the bottom with only their powerful jaws exposed. When an ant or other small insect tumbles down the slope, the larva flicks sand upward, causing mini avalanches that prevent the prey from escaping. It's a perfect ambush, engineered entirely by an insect no bigger than a grain of rice. What's remarkable is how these larvae choose their location. They need sand that's dry enough to flow freely but stable enough to hold the cone shape, and they require protection from rain and wind. The spots where these pits cluster tell us about the microclimate of the beach, areas sheltered by dune grass or slight depressions that stay dry even during storms. In their own way, these tiny predators are reading the landscape just as carefully as any scientist. Look toward the dunes now, where beach grasses give way to low, spreading vines with thick, waxy leaves. That's beach morning glory, also called railroad vine, and it plays a crucial role in stabilizing the sand before the taller grasses can take hold. This plant is a marvel of drought and salt tolerance. Its leaves are coated with a waxy cuticle that reflects sunlight and reduces water loss, while its deep taproot can extend 10 feet or more into the sand to find moisture. But here's the truly ingenious adaptation. Beach morning glory can actually excrete excess salt through specialized glands in its leaves. If you look closely on a sunny morning after a storm, you might see tiny salt crystals on the leaf surfaces where the plant has expelled the salt it absorbed from spray and sand. This ability to not just tolerate salt but actively remove it from its system allows the plant to thrive in an environment that would kill most other vegetation. These pioneering plants create patches of stability and shade, slowly transforming raw sand into soil that can support a more diverse plant community. As we walk, take a moment to look at the horizon where sea meets sky. On clear days like this, you can sometimes see a slight flattening or even a faint green flash at the moment the sun touches the water, though that's an evening phenomenon. But what you're seeing right now is something equally subtle, the curvature of the Earth itself. The horizon at sea level is only about 3 miles away due to the planet's curvature. That ship barely visible on the horizon, seemingly half submerged? It's not sinking. You're seeing the reality that Earth is a sphere, and the ship's hull has dropped below your line of sight over the curve of the planet. Ancient sailors understood this phenomenon instinctively. They knew that the higher they climbed in a ship's rigging, the farther they could see, because they were effectively increasing their personal horizon distance. From the beach where we stand, we can see about 3 miles out. From the top of a nearby lighthouse, perhaps 70 feet high, the visible horizon extends to over 10 miles. The ocean reminds us constantly that we live on a globe spinning through space, even as we feel motionless on this peaceful shore. Listen now to a different kind of sound mixing with the waves, that sharp, chattering call. That's a common term, but it's not just calling randomly. Terns and other seabirds have distinct vocalizations for different purposes: alarm calls that warn of predators, contact calls that keep a flock together, and begging calls from chicks demanding food. Scientists have discovered that some seabird chicks learn their parents' individual calls while still in the egg, before hatching. In the chaos of a crowded nesting colony with thousands of birds, a parent returning with food can call out, and their specific chick will respond, allowing them to reunite despite the crowd. Even more fascinating, some seabirds pass down foraging knowledge across generations through observation and memory. Young terns follow their parents to productive fishing areas and learn not just techniques but specific locations. A particularly good fishing spot might be known to a family line of birds for decades, with knowledge passed from parent to offspring in an avian tradition older than human memory of these shores. As our walk draws near its close, notice those small, perfectly round holes in the sand we've been passing all along? We mentioned mole crabs earlier, but there's another architect at work here, the acorn worm. These soft-bodied creatures, related to sea stars and sea urchins, live in U-shaped burrows and feed by ingesting sand at one end and expelling it at the other, extracting any organic material in the process. What you see on the surface are the little coils of processed sand they've left behind, miniature sculptures created by an animal few people ever see. Acorn worms are living fossils in the truest sense. Their body plan has remained essentially unchanged for over 500 million years, and they represent one of the earliest branches of Durastomes, the lineage that eventually gave rise to all vertebrates, including us. In a very real sense, these humble worms burrowing beneath the beach are our distant cousins, sharing a common ancestor from the Cambrian seas. Every coil of sand they leave on the surface connects us to the deepest roots of our own evolutionary tree. As we complete our journey and turn to look back at the path we've traveled, Notice how our footprints tell a story in the sand, a temporary record of our passage that the next tide will erase. But the beach itself is also leaving records that will last far longer. The layers of sand being deposited here, mixed with shells and organic matter, are slowly becoming sedimentary rock. Millions of years from now, long after human civilization has risen and fallen, these sands might be compressed into sandstone, carrying fossils of the creatures we've observed today, the shells, the crab burrows, even the ripple marks formed by waves. Geologists reading those rocks in some distant future will be able to reconstruct this moment, a peaceful beach on a calm day in the early 21st century, when the ocean was at a particular level and the climate was shifting. We are literally walking through both the present and the deep future simultaneously, each step contributing to Earth's geological memory. As the waves continue their eternal rhythm and the birds call overhead, we're reminded that this beach is a place where past, present, and future converge, where ancient minerals meet modern life, where processes millions of years old create beauty in each moment, and where the simple act of walking becomes a journey through time itself. Thank you for joining us on this peaceful walk along the eastern seashore. May the calm of these waves and the wisdom of this ancient coast stay with you, wherever your own journey leads.